So as we said, last topology that we is a hybrid topology. In this case, we have a hybrid, this bus, and if we look at this hub, central, and link is star topology. So it's bus star topology. They can be different combinations of topologies. Now we'll talk about the categories of networks. We have actually three broad categories of networks: the local area networks, or LANs we call them. Local, you see the name local infers that it's a small place or the short distance, so it's local area. It's normally limited in size, so it's not very big network. So the network at your home is a local area network. The network at your department or college is a local area network. It's actually designed to provide local interconnectivity, and a LAN interconnects hosts. So you have different hosts that interconnect with this LAN. So local means distances are short normally. Okay. The next topology, the category, not topology, sorry, is the metropolitan area network. MAN we call them. Metropolitan means is from city or campus. So we mean by metropolitan that a network that provides connectivity over areas such as a city or a campus. Okay, so the whole University of the whole network, we can call it a metropolitan area network because we have different campuses, they are all interconnected to make a metropolitan area network. It's actually metropolitan area network is owned by private company, or it may be a service provided by public company such as a local tele company. For example, the company that provides fiber communication, we can call their network a metropolitan area network. Maybe single network such as a cable television network, or it may be connected number of LANs into a large network so that resources may be shared LAN to LAN. In this case, for example, we have LANs in our college, then they are interconnected to each other, and we have different campuses, so we can call the University of the whole network a MAN, metropolitan area network. And we have wide area networks, or WANs. So wide area, from the name wide, we mean long distances. WAN has a wider geographical span, so instead of one city, it may span a whole town, a state, or a country. Whole country can be a single one, or even the whole world. For example, a company that has many branches in different cities, different countries, different continents. So their whole network is a WAN. They have local networks, they have metropolitan networks, they have all together connected to make a WAN. Okay. Provide connectivity over large areas. A WAN interconnects connecting devices such as we need, of course, switches, routers, and modems in this one. So we have three categories of networks: local, metropolitan, and wide area networks. Okay, you have to recognize these categories. Okay, it's important. When I call you, when I ask you what's the type of this network, you have to be able to classify it to these. Actually, we have another one which is called PAN, Personal Area Network. It's even smaller than one, because nowadays we use different devices, sensors connected to uh, uh, like human body, so you can call that a PAN, Personal Area Network. In this case, distances are even shorter. For example, we are talking about 1 meter distance or even less. Okay, this is another category of network. So generally we have LANs, MANs and WANs. This is an example of a local area network. This is a single building, for example, or room, another room or lab. These all together make a LAN. Okay, this is also a LAN. So you have server room, you have one LAN, another LAN, another LAN. They are all interconnected with this. So it's also a LAN. This is not a WAN because it's same place. They are close to each other in the same, for example, say building, different rooms. This is a LAN. Here we have a metropolitan area network. So you see different topologies, like here is bus topology, here is bus, here is what's the topology here? What's the topology? What's the topology? Who can answer?
Star topology.
Very good. And this topology, what's the topology here? Sorry, why the pen is not. The one on the left, top left, what's the topology?
Ring topology.
Okay, so we have different LANs in the city. They are all interconnected and we call the whole network a MAN, Metropolitan Area Network. Okay, so now we have one wide area network. In wide area network, as we said, we have different LANs or even MANs, all interconnected using routers, switches, hubs, whatever communication devices, interconnection devices, all together will construct a wide area network or WAN. So the span of WAN can be a city, a country, a continent, the whole world can be the scope of a WAN. In this case, for example, you see this is a WAN, so it spans over the whole world. It provides long distance transmission of data, voice, image and video information over large area, country or whole world. In contrast to LAN, WAN may utilize public or private communication equipment or combination. So when you go from here to here, for example, from point to another point, you go through public and private networks maybe. Here comes the security issue. So how your data is handled when you communicate through this or these links. Therefore, we need different technologies to secure our data, like VPN or encryption. Point-to-point one, actually, one devices normally use point-to-point connection. So this may be a router, another router. They connect to each other using point-to-point communication links. We talk about this later in this course. Switched one. In switched one, a switched one is a network with more than two ends. So if for example here you see there are more than two ends, not like this one. A switched one is used in the backbone of global communication today. A switched one can be seen as a combination of several point-to-point. So here is point-to-point. You can think of this as a point-to-point. You can think of this as also a point-to-point. So it's a combination of several point-to-point ones that are connected by switches. So this is switched. Before it was mainly this one in use, but nowadays we use switched ones. To connect these devices or these we need internetwork. And internet, you see the term internet and the term internet with capital, we mean different. Capital I. A small I is two or more networks that can communicate with each other. So this is a network, a WAN or a LAN, mainly LAN, or they connect to each other. We can call this an internet with small I. But internet with capital I, you know what's internet. The whole network of the whole world is called internet with capital I. But a small I internet means any two or more networks, another network connected to this. So we call this internet or internetwork. We have the term switching, packet switching and circuit switching. Is fundamental and easy actually. So in circuit switching, we just remember the old telephony system. So you are the caller here. You want to call this subscriber, so you connect here. They will establish a connection, okay, to the link. Then this will make a connection to this, so you have a full link. Now the link is established, you can communicate. This is called a circuit switch. You have to be connected, okay. You call this station. When you communicate, this will connect you to this link, okay. You want to connect to this subscriber. When you're here, it will connect you to this, so a circuit is established, okay. Now when you talk, you have the dedicated link. Okay, if you want to talk to another one, you have to connect to this. So all your data will go, or your that way only. This is called circuit switched. In packet switch, we don't have an established circuit. Okay, so we have packets. We send packets. For example, this one wants to communicate to this. We send packet. This one, the router will send the packet, and then the router here will send the packet. There is no fixed link. So if you have many routers in between, let's say something like this. So there are many links from source to destination. So when this one sends data to this one, in the first time the packet this way, but the second packet may go another route because there is no established circuit. Okay, you just send the packet, and the routing protocols will handle the forwarding of the packet, so the packet can go through any of these routes. We study routing protocols later and we'll understand how this happens. Okay, so we have circuit switched and packet switched network. In circuit switch, when the circuit is established, so all the communication will go through that link. You need to establish the link before the communication takes place. But in packet switching, you don't need the link. You just send the packets, and packets will be routed to the destination. Of course, in this case, this packet should have all the information that will help it to get to the destination. Otherwise, it will get lost. On the last slide, I think, is the internet. Here we mean the whole network of the world. The most notable internet is called, so internet is also an internet, but with capital I we mean is composed of thousands of interconnected networks. It's actually the whole worldwide networks all together will make the internet. And that's it for today. I think that's the last slide. Yes. Just one second, I'll give you some time to have your questions answered.